Okay, what I'm going to do is start out with the introduction, which is module number 1 on your agenda. And what I'm going to do during this introduction is first give you a brief history of this course, slope maintenance and slide restoration for highways. I'm going to tell you why and how the course was developed, and then I'm going to give you a quick overview of the course. Tell you what it is that we're going to be covering, Barry and I, for the next couple of days. Let me get my glasses on so I can see which one is forward here. Okay, about 20 some odd years ago, we received a lot of calls from many state DOTs on a nationwide basis that they were having a lot of slope problems, not only on the interstate highway, but in many of their rural highways. And what they were reporting was many slope failures that were occurring very frequently, and it was becoming a major problem, major maintenance problem for them, and it was a continuing maintenance problem. They were reporting these problems, like I said, not only on the interstate, but on their primary highways, secondary rural highways. So, they were talking about a significant number of slope failures. And it was having a budgetary impact on the maintenance program in terms of time, personnel, equipment, and materials. So, to begin, let's look at the types of problems that maintenance was reporting to us. And I'm sorry, but I'm going to be in your way here for a little while. This is not the type of maintenance problems that they were recording. This gigantic type failures that completely removed the roadway was not the type of problem they were reporting, because these big failures that occur normally get political attention. And normally your state geotechnical people would be involved on that. Either the state geotech people or geotechnical consultants are hired in order to reopen this highways, like this big failure up in Oregon. The previous one was the one up in New York State. Okay, so what was the type of problem that was being reported by maintenance people? It was more of this smaller type problem. You see a small slough landslide that is taking place here. It's getting close to the roadway here, so it's beginning to be a maintenance concern here. Same thing with this one. There's some flow that is coming out here. It's beginning to have an impact on the guardrail. So this was a type of problem that was being reported by the state maintenance people. Many of the causes that were involved with these small failures were either not identified or unknown. And the reason for this is that most state DOTs do not have a maintenance item for landslide repair. As you all know, maintenance has a maintenance item for guardrail repair, crack sealing, overlays, that kind of stuff. But, those things were being applied to correct some of these slope failures. So a lot of these costs were not really identifiable, but mainly state DOTs. But the bottom line was that it was a major maintenance problem for a lot of these state DOTs. Around this time, I went out and met with a lot of state maintenance people, state district construction people that were handling some of these problems to find out what the standard practice was at that time. And what I wanted to do was find out who was a responsible person for this kinds of small slides. And again, we're talking about smaller slides like this one. Okay, so who was responsible? I want to find out the types of analysis that were done. What types of analysis do most maintenance people do, or field district construction people do for these kinds of problems? Do you maintenance people do any kinds of analysis here yourselves? District construction people? What I found out was that in the normal case was that the district maintenance construction people really did very little or no analysis here. And I wanted to find out the different types of correction methods that were being utilized. And I found that there were a lot of very innovative things that were being done by state district construction and maintenance people. So we went out and some were not really working well. So let me just show you a couple of examples of what we found kind of on a nationwide basis. Let's drive up here on, say, Interstate 70 here, and we see a problem that's occurring on one of the approach embankments there. And we go out and look at that, and we see the maintenance supervisor out there with this maintenance guy there, and they're looking at this failure here, and it's getting close to the shoulder. It's already impacting the guardrail there, so they're thinking that something needs to be done here pretty soon because it's going to affect the shoulder and affect the safety of the traveling public here. So one of the things that was being done and still being done kind of on a nationwide basis is that they'll go out there and remove the failed material that has taken place, stick it on the site, let it dry, and then push it back up. Very little compaction. The only compaction that really takes place is by the tractor that is pushing this material back up. And that's really the repair that is being done. And how effective do you think this repair and how long term do you think it's going to be? Not very good. Because about 6 months later, they're back at the same site again, looking at the same failure. And this time it's really progressed a little bit more. Now it's going into the shoulder out there. So, this is not a good way of correcting this types of failures. But, again, it's being done nationwide. Let's look at another short case history here. This time we're kind of in a rural area here, kind of in a mountainous area, maybe around the Cambridge area here. And we see this highway here where maintenance is already going out there and put in a rough road, because if you look closely here, any vehicles coming through here will become airborne because there's a little slump that is taking place there, some settlement. And so they want to take a close look at this and see what's happening. So let's look a little bit closer out there and see what's going on. We can see that there's some differential settlement taking place there, and it's a small failure that is already starting to take place. But what do maintenance people normally do when they have cracks on the highway? They go and seal the cracks. And I also mentioned that there was a differential movement that was taking place there, so there was a slump there. So the other thing that maintenance is going to do here is go out there and put an overlay. And that's normally what's done on these roads. They need to level up the highway so that traffic traveling through there at about 35, 40 miles an hour is not going to go airborne, and so it will not be a safety concern. So that's what they do here. They go ahead and overlay it and put in a little guardrail there just for safety purposes. And then, they go back and this happens several times where they have to do several overlays. And over a period of time, they put so much weight in there that they actually create a failure like this. So going back and forth and doing some more crack sealing and more overlays puts a lot more weight in there and eventually causes a failure. And this is the geotech engineer from your neighboring state here in Kentucky, Henry. This guy is about 6'6", I think he is, and he's measuring almost 5 feet of asphalt material that has been placed here by maintenance on this landslide that has been creeping for years. Maintenance has been coming up and overlaying and overlaying and overlaying to where they have 5 feet. Luckily, maintenance went up and reported this to the geotech people, and they went out there and designed a correction method before the whole thing failed. But they had to remove about 5 feet of asphalt, and as you all know, asphalt weighs a little bit more than soil, so that was a significant amount of weight that was being added there. So obviously it's not a good correction. It's maintenance doing their job out there, but it's not correcting the slope failure. So what we did at that point was put together a multi-state study to come up with some guidelines that would be addressed at the maintenance, the district construction people that would normally be handling those small failures. And we put together 6 states. Well, I can't see the bottom ones there.
Wyoming.
Let me just lift it up here because I can't remember who all the states were there. See, there were a total of 6 states: California, Kentucky, Pennsylvania, Oregon, Texas, and Wyoming. Each of these states provided a geotech engineer, a maintenance guy, and a construction engineer. And we had different meetings in different states like this and came up with guidelines for addressed at the maintenance supervisor to address how to really maintain, how to correct some of those small failures. And this is what came out of that study, a guideline manual. This was distributed nationwide. And then the state DOTs came back and said, yeah, these guidelines are really great, but we would really like to have a workshop so that we can talk to the maintenance people and actually show them some other case histories and show them what's in the manual. So from there is where the manual that you all have. Do you all have a copy of the manual? Yes? Okay, great. So that's where this manual was developed. Tommy Hopkins from the University of Kentucky was the one that actually put the manual together, and the workshop that we went and total over the U.S. Several years ago. Okay, the scope of the workshop was to address this so-called minor slides, because a minor slide in say Oregon or Washington DOT could be a very big slide, maybe down in Texas or Mississippi or maybe even in Ohio. So that's why it's called minor slides. So but some of the smaller slides is what this workshop is dealing with, and it was primarily addressed at the maintenance supervisor. So the purpose of this workshop is to provide slide maintenance and slope restoration guidelines for state, county, city maintenance supervisor. And I think that this course is also of interest to our geotech people, to construction people, to our design people, because a lot of problems that develop during maintenance are really design failures. At least that's what I tell our design people when I go and talk to them, that you maintenance guys are having to deal with a lot of these problems. See, how many of you are involved in maintenance activities? Can I just see Great, we have a lot of you guys. How many of you are geotech engineers or involved in geotech? Great, we have several of you here. Do we have any construction engineers? District construction. Great, we have some construction engineers. How about design engineers? Great, we have some of you guys here too. Uh-oh.
How about lawyers?
No lawyers. And then we have some of our FHWA people here as well. So great. So this is the purpose of this course. Okay, and this is a summary of what it is that we're going to be covering. It pretty much follows the agenda that you have. We're going to go through slope movements, recognition, maintenance practices, and then to kind of add a little bit to of information for the maintenance and construction people, I went ahead and added a little section here on design. We won't really go into very difficult formulas or anything like that, but we're going to talk a little bit about how geotechnical engineers do their slope analysis and their slope designs before we get into actual discussions of how to develop correction methods for landslides. And again, those correction methods are something that our design people should be doing during design so that they don't become landslides and maintenance problems and correction methods that we have to deal with. But we're going to spend a lot of time talking about different kinds of methods of correcting some of these problems. And then we're going to end the workshop. Barry's going to talk about legal liabilities of these slope problems. Okay, so the next few slides are just going to be a quick overview of what this course is going to be covered, what Barry and I are going to talk about here for today and tomorrow. Okay, this workshop was developed to address all of the geological landforms on a nationwide basis. So we're going to cover different aspects here with emphasis on the landforms and geologic conditions that you guys have here in Ohio. So we're going to be talking about slope failures. Barry and I are going to show you all kinds of different kinds of soil failures. We're going to classify the different kinds of failures and show you some of the things that maintenance is doing out there that is not really working. We'll show you why the driving a piling to try and correct a failure like this is really ineffective and just a waste of maintenance money. So we're going to talk about a lot of slope failures. Again, identify the failure, show you why it's so important to identify the different kinds of failures that we have in soils. And then we're also going to talk about rock. We're going to show you different kinds of rock failures, and again, identify the different rock failures that occur. So Andy, there's a whole NHI course just on rock slopes that Duncan Wiley teaches for those geotechs that want to get more detailed into that. Have you guys had the rock slopes course here in Ohio with Duncan Wiley yet? No? If you have a lot of rock problems, that might be a course that you would be interested in having. Okay, another problem associated with rock slopes is that of rock fall. You all maintenance guys know that in some of these rock cuts, some of those rocks will come down and land on the right-of-way there. And rocks that are on the right-way can be a big safety concern. A vehicle traveling at maybe not even a very high speed can have accidents because of those rocks in there. So it's a big safety concern with the rocks that fall down, and some of those rocks may actually fall on the actual car itself. So that can be a major impact. This guy never knew what really hit him here. He just didn't make it. And this is a very serious problem nationwide. There's been many fatalities that have been reported in many state DOTs from New York all the way to California. This particular one is in the state of New Mexico, where a boulder came off one of the high rock cuts that they had out there and crashed into this bus and killed 5 people there and injured some others. So it can be a pretty big problem, and we're going to show you ways of maintaining your slopes and correcting so that you can take care of those boulders out there before they come down and actually do damage out there. Okay, another module, the second module in your agenda there in this course is going to talk about what makes slopes move. Why do we have slope failures? So we're going to get into a little detailed discussions as to why this slopes failure. Before we can make corrections to this slope failures, we have to understand why it is that they fail. So we're going to get into the causes of slope failures. We're going to talk about why this slope is failing here, and show you why this is really a big design error. You know, designers should have known better than to do something like this and cause this maintenance problems for the maintenance people. The workshop is going to get into discussion of distressed items. You know, you maintenance guys are out there driving the different highways, and you know, what should you be looking for? They'll give you symptoms of a potential problem. And we're going to talk, you know, some of the things that might be occurring out there in terms of either cracks or moisture or maybe bulges in different places that can tell you that there's a problem developing. We want to do this because correcting a small failure such as this one is much more economical than if this grows, and grow it will. If maintenance can detect the symptoms of a small failure and correct it before it becomes a bigger failure or maybe even a much bigger failure, you know, the correction methods are going to be much less. And you know, things like that have actually occurred in construction projects where, you know, there'll be a project and they'll start doing some excavation and some small failures start to happen, and construction people don't really recognize the symptoms, and they say, well, you know, make a bigger cut, so they keep cutting, and before they know it, they're cutting the whole mountain out there. So we're going to talk about some of the symptoms that you should recognize so that that small problem does not become a gigantic problem like this one here. Okay, another module is going to address the maintenance practices for this small, so-called small slides. And we're going to emphasize several things that we're going to recommend that the maintenance do not do. And we're going to recommend some preventive type maintenance practices that maintenance people can do out there to prevent some failures from taking place, or at least control them. And like I mentioned, I added a module to this course where we're going to talk a little bit about the analysis that geotechnical engineers use in order to design this soil slopes and make sure that they are safe before putting their stamp on the plans. So just a little bit on design analysis as well. And we're going to make, Barry and I are going to make a lot of emphasis on the importance of knowing where the failure surfaces. Like I said, we're going to identify different types of slides, and as shown here, but we're going to put emphasis on knowing where that failure surface is. And maybe we'll give you kind of an introductory quiz here. Let's find out what you guys can recommend here. Here we have a typical project that is being constructed on a side hill. This fill has been placed here. You can see that this is the original embankment that was, or the original fill, the embankment that was constructed there. And this was completed about a year ago. And maintenance people are already noticing some cracks that are occurring here in the slope, and there's a little bit of differential settlement that is taking place here. And so the maintenance guy says, well, why don't we go ahead and flatten the slope on this one? You know, flattening the slope corrected the failure that we had last year. So let's go ahead and flatten the slope here. Now, is flattening the slope here going to correct that problem? How many say yes? How many say no? How many don't know?
I don't know. I don't know what's under that.
Okay. Yeah, we don't know what's under there, but I'm showing you where the failure plane is. And that's, you know, in the previous slide I mentioned the importance of knowing where that failure, the plane is.
I've done that, Andy. Right there.
Okay. Again,
Cost a fortune.
yes. Indicating that it is highly important to know where the failure plane is, and to do that, you're right, you have to know what the subsurface conditions are. And that's why I'm going to go a little bit into analysis to do that. But the importance of knowing where that failure surface is highlighted here. Okay, we've already kind of shown where the failure surface is here. We've done some analysis there and subsurface investigation, and we know what's happening. Maybe we have some instrumentation here that showed us where that failure surface was. So the answer here was, this correction method is not going to work at all. In fact, what we may be doing here is actually adding more weight to this slope. As you'll see when we do analysis, we'll have some driving forces and resisting forces, and we're actually adding weight here where we're actually pushing this slide to fail. So by maintenance flattening the slope here, they're actually aggravating the problem, and this failure actually happened much sooner than it would have if the slope had not been flattened, as shown here. Because they came in, added weight, and then caused a failure here. What you're going to find later on is that we need to find out where this failure plane is, and then maybe add some weight down here. What we want to do is hold this slide from pushing out. We want to add resisting forces in this area there. So this would not be a good solution for this problem, and it would actually aggravate the problem and cause a failure much sooner. So not a good solution, and we're going to talk a lot about this kinds of stuff. Okay, so that slope failed, and maintenance very properly went up there and put the sign in. That's a big safety item. We have to protect the driving public here, so that somebody doesn't come here at night and run off the highway there. Okay, so we have failures, and we're going to spend a lot of time talking about different methods that are available to correct some of these slope failures. We're going to spend hours tomorrow talking about this kind of stuff. And then the last module on your agenda there is to talk about the legal aspects of some of these slope movements. And Barry's going to finish the course tomorrow talking about this and answering the question of who's liable for this railroad track being bent out of shape and the railroad or the train coming through here and derailing, maybe causing injuries there or stuff like this. Who's liable for that kind of stuff? Who's liable for the loss of property on this homeowner here when there's a highway cut over here and they initiated a failure and it's causing distress on this particular house? They can't really hire a geotech guy to go out there and hold on to this property for the rest of his life there. So, we need to do something else. That was your truth, myself right there about 30 years ago up in Oregon, where they had a big coastal highway slide and impacting some of the residents out there. God, I forgot they even made pens like that before. Wow. I don't know how in the hell I wore those pens. Okay, so that's pretty much a summary of what the course is. And again, the purpose is to provide this slight maintenance and slight restoration guidelines for all of these people. And like I mentioned, it's not only of interest to our maintenance people, but it should be of interest to the design people, the construction people, our geotechnical people, I think, will have interest in what we're going to talk about here today. So with that, Barry, you want to continue here, or you want to? You're not ready for a break yet.
No, we'll get into the main topics which we think are interest to y'all. You should have your workbook in front of you. Mark, would you? Everybody should have a workbook. What we will do is, if you'll just open this for a moment. This is going to be a reference manual for you. If you go to Roman numeral 3, the triple I and the table of contents, this is our course outline. It is exactly as your agenda indicates, with the exception of the one area that Andy mentioned, which is he's going to talk about the design concepts. He's not going to go, try to make you all engineers. But what we try to emphasize here is that when you're looking at a small slide, you are making, if you're a maintenance person, you need to make the same judgments that the geotech engineer will make. And we want to be able to cover what can be done quickly in the field using good judgment. And what point do you stop putting in overlays? So like Andy said, in Kentucky they had 5 feet of asphalt. When do you say, we got a problem, we don't want to spend our maintenance funds on that, let's call central office and get Chris down and see if he can come up with an economical solution?
Again, I'm Chris Northland. I'm the design, or geotechnical design coordinator in central office. I've been with ODOT 6 months now, and when Gene asked me to do this talk, I said, well, he gave me a whole bunch of slides, probably 200 slides to look at, literal slides like you put in the tray, not slides like we're talking about here. And I started looking at those, and I thought, well, gee whiz, that's not going to make a lot of sense, me just going through a bunch of slides that I hadn't worked on or participated in. So I found out that in my first 6 months, I've worked on enough slides already to make up my own presentation here. As a matter of fact, I probably have worked on more slides in the first 6 months here than I did in my previous 11 years of practice in the consulting side. So that kind of emphasizes the importance of slides in the highway system and how much they are a part of our daily lives. In my short time here at ODOT, 2 things I'm not used to yet. One are all the acronyms. I have no idea what the alphabet soup that we deal with every day is. I learn that all the time. And the other one is referring to everyone by their last name. So it might have been more effective to put our last names on our name tags. We would know each other. Anyway, I'm going to talk about the ODOT experience and practices with slides. Make sure I get everything here. Remedial measures. Like Bob mentioned, we're going to come up with some funding of ways to fix slides. In this room, we're probably more used to maintaining them rather than fixing them. By the time they hit our office, our primary intent is to fix them so that they're a slide no more. And basically, in the words of Terzaghi, if a slope has started to move, the means for stopping movement must be adapted to the processes which started the slide. Seems simple enough. In this statement, the most complicated thing that I see is, first of all, identifying the processes, and then second most complicated thing is figuring out how to stop the processes. First thing we do in our office is we try to determine the processes or the things that are causing the slide. A brief summary of the things we do to try to find this out. First and foremost is a site reconnaissance and planning process. We visit the site, take a look at the slide, try to take in everything we possibly can with respect to the surroundings and things that we feel are causing the slide. Even prior to that, we're looking at documentation, topography maps, bedrock geology, bedrock topography, and trying to get a good feel for what's going on in this area. It's extremely important that our office, anyone from our office or anyone in general, get their hands on everything that's happened in a particular area with respect to existing plans, what the original ground line was when construction took place, any maintenance history. That's extremely important, and of course, talking to everyone in this room, we're all familiar with maintenance history documentation. It may or may not exist, so it's important that you talk to as many people as you can that would know as much as we can find out about a particular situation. And then survey site conditions as they exist today, so that we can look at cross sections, look at the alignment, and overlay it on the way it was supposed to look or the way it was built to see what kind of movements have taken place. I emphasize that step is not optional. It must occur if we're going to fix a slide, whether we're doing it or whether you're doing it. All of that information has to be tabulated, compiled, and plugged into the equation. Drilling and testing, again, another very valuable tool in determining the process that caused the slide. It doesn't happen in every case. Sometimes what's occurred is obvious from a visual evaluation, and also another restraint is time. Sometimes we just don't have time to mobilize drill rigs and do elaborate testing to better the situation. I know that's not the ideal answer, but that's the reality of it a lot of times. And so we utilize drilling and testing whenever we're unsure of a situation and want to define it further, or establish some sort of information for our analysis. Instrumentation and groundwater monitoring, again, goes along with drilling and testing. If we're wanting to define the scarp, we'll utilize those types of monitoring and modeling and back analysis. Back analysis seems kind of screwy. As an engineer, you want to have all the answers up front and stick it into an equation and come out with the right answer. But the reality of it is that you actually have to identify a failure, basically a factor of safety less than 1 first, and then look at your situation and see what is causing that factor of safety less than 1. And so you almost begin at the end and work it backwards. You take the information you have and you plug it in, and sometimes that doesn't create the failure, so you're obviously not modeling your situation exactly right. After determining the processes, with that information we design a fix to fix our slide. 4 major categories of remedial measures. The most popular is drainage. Trying to get water out of a site. It also includes vegetation, something that we probably don't utilize enough to take care of drainage, but putting in vegetation is one way of draining in addition to putting in pipes. An example of a project that our office has worked on, it's a pretty sizable project with respect to drainage. In this case, we had a scarp down here on the outslope of an embankment, and basically everything here is down gradient in this direction, so up gradient's over here. There was a large culvert right here, and when we went and took a look at this site, Kirk was one of the primary investigators on this project. In this median here, it's kind of a V-shaped median, and in the slopes here we saw some water seeps. And also, I believe there are some seeps over here as well, in the scarp area. After a lot of investigation, we basically decided to put in this curtain drainage right here to cut off all the drainage coming from this direction that was causing this failure here. And also some drainage was put across the road to cut off any water coming down the granular base of the roadway. And this was done by, or is being done, it's under construction right now, by drilled shafts side by side, and basically filling the drill shaft with granular material, and that serves as the curtain drainage or the cutoff to all of the upgradient water. And then of course the slope gets rebuilt. So in profile it looks like this. Looks pretty ominous, all of that drilling and side-by-side excavation to solve the problem, but basically in the end that was really the only way to alleviate the source of the water and protect the slope for the long term. One other option we were considering here, again this is a pretty complex situation, we don't deal with these all the time, but we were actually considering drilling caissons with further spacing, not necessarily side by side, and actually directional drill a tile or a drain system through those, connecting them to get the water out that way. But the consultant we were working with, they just couldn't comprehend that idea, and so therefore this ended up coming out. Those consultants just don't know what they're talking about. That's why I'm here today. Second most popular method of remedial measure is removal. Pretty straightforward. We're cutting out the failed material. In most cases, trying to bench into a foundation soil or rock that is not failed, that's stronger, and then rebuilding it so that we're reinforcing it. This is another project that I worked on in District 10, Noble 77. This is an embankment outslope. I didn't quite get all the picture in there, but it's a progressive failure. It started down here at the bottom, and an initial slide at the bottom, and then it just worked its way up until it became critical. When we see it behind the guardrail there, then we get anxious, or Bob gets anxious. I get anxious when it's down here, but as you can see, it's a pretty bad situation at this point. One of the primary means of fixing this was removal, was digging out all of the failed material and then rebuilding this outslope of the embankment. We'll come back to this project in particular in a later slide. Third remedial measure is restraint. Restraint seems simple enough, but it includes several different options. Counter berms, there are walls, there's several different types of walls in and of itself. Even lime modified soil is considered a restraint because it strengthens the soil and tries to eliminate the failure that way. A good example of a project I worked on in the beginning of restraint was right here. We've got 3 different restraining systems all within probably one of my drivers of each other, which is only about 100 yards or so. Here's a counterfort wall. Right here is a sheet pile wall, and right over here is a geogrid reinforced slope. The problem in this situation was this counterfort wall was being scoured, and the toe was being removed that way, and so then the shoulder along the road dropped, and the whole thing began to slide. Bedrock is in the creek or very shallow there. Down here, this slope here was built a little steep. It's about a 1-to-1, and it also was showing signs of movement indicated by the leaning pole there. And this creek here is connected to the Ohio River, and so I guess flows through here can be extremely rapid. So the scour was something that wasn't necessarily going to go away. Plus, we couldn't do anything with the stream with respect to just simply creating a toe there again for this counterfort wall. So the solution in this case was actually to introduce a 4th type of wall. We're going to put in drilled caissons, cantilever case on-socketed into rock along the roadway here. So good example of, this, of the many different kind of restraining systems you can have for the same situation. This gives an example of another job, Lawrence 775, that we worked on, of a restraining system. It's a cantilever wall, H-piling in this case. You can see the bedrock, estimated bedrock surface is right here, so you'll have a solid foundation. The failed soil basically is in here, and what we want to do is we want to, this is the roadway in here also, we want to basically keep that soil all in there, and we're going to utilize the rock to do that. And so what we're going to do is, in this case, is socket the H-piling into bedrock and use concrete lagging between the H-piles to restrain this soil in this case. Pretty popular option when you have a shallow bedrock that you can use to cantilever in. I think we created some standard stuff for District 11 with respect to drill shafts, and I think Jim uses drill shafts socketed into rock quite a bit. And the fourth major category of remedial measures is relocation. I don't know if it's a blessing or a curse to have been involved in probably the most difficult project I'll ever participate in the first 6 months of my career, but I guess getting it out of the way first is okay with me. This is the job that I think Jim and George were talking about as one of the most memorable or the most difficult or the most the worst job they ever worked on. I don't know which, but this is the Bell 7 3.68 job where in the colluvial there was a slide starting to take place that towed out. Here's the river right here, and after much investigation it was figured that the tow was somewhere out in the middle of the river, and the amount of soil that was failing was just immense. Three things were considered. First, trying to restrain, as we talked about previously, the soil mass that was failing, and with some thought there, I think it was decided that we're looking at 12-foot diameter side-by-side caissons with substantial reinforcement that are going, who knows, 50 or 60 feet deep, even deeper, socketed into rock, or we're building a rock berm somewhere in the river, and I don't think the Corps would be too happy with us putting 30 feet of stone in the river halfway out. So restraint was considered not really practical in this case. We also did a groundwater study to find out if we could actually unload the top part of the slide by dewatering it, and with pump tests we decided that we just simply couldn't pump enough water out to unload it that way. So drainage was considered. What seemed to be most feasible at the time was relocation. And so you can see the road's at this alignment right now, and we're moving it over to this alignment. And there's not enough time in the day to talk about all of the situations in this project, so I'm just going to leave it at that as an example of relocation. Although one measure is dominant, most slide repairs involve the use of two or more categories. Relatively simple example here, but who was blaming all the geotechnical engineers for all the embankment failures? Was that you, Dan? Okay, don't call me. This wasn't our fault. This is that Noble 77 slide, pretty straightforward situation. First of all, one idea, of course, was removal. It seemed obvious to get rid of all the failed material that was down here, and we're going to come in here and we created, which I don't have here today, but we created a benching detail to come in and remove everything that was failed and get behind the scarp, which we can obviously see the scarp here. Also, this fill is in a valley between two valley walls. We don't know exactly where water is coming from, but it's easy enough to put bench drains in and try to alleviate water in this situation. So we can estimate that water could be coming out of springs in the adjacent valley walls, and then in time it basically popped this slide here. So we're going to include drainage in there as well, and we're also going to utilize restraint in the means of a flatter slope. Andy, I think, gave an example earlier about a flatter slope not working in that situation. Well, here's a situation where we're going to utilize it, and it's not so much to stop. In that case, I think the slide dipped into the foundation soils. In this case, it's purely in the embankment itself, and the foundation is rock, and so the restraint is more of a to accommodate the fact that we expect weak soils to be used to fill this back in, just because it's inherent in the area. So therefore, we're going to flatten it out as much as we possibly can. Rather than a 2 to 1, we're going to go 2.5 to 1 because the right-of-way allows it, and that will give the red shale that could be used here that Jim mentioned has a really poor strength. It'll give it a little flatter situation to not fail in the future. We also deal with a number of levels of effectiveness and levels of acceptability. By that I mean that there's some slides we just deal with respect to maintenance. We choose to live with them. We decide they pose no significant hazard to the public but require periodic maintenance. In my short career, a good example I saw of this was on MEGS 338. You guys in District 10, I'm sure, are real familiar with what I'm talking about. It looked like a roller coaster to me. An awful lot of asphalt out there. There have been some slide repairs, but in general, to fix everything out there would be extremely high cost, and the traffic volume evidently is so low it just doesn't justify the need. So it's something that District 10 just lives with for the most part.
I figured get you started with the low ones, you come down and fix it big.
Is that right? Break me in, I appreciate it. District 11 isn't so kind. The other thing is effectiveness of fix. Example I came up with in my experience here was Washington 7. It was a relatively small embankment failure again. The best I could tell from my research is that this area had been dug out and replaced in 1989, and here it was in 2002, popped up again and failed again. A contractor gave a solution or a restraint system that was pretty much pretty new, hadn't really been incorporated in anything that ODOT had done or anything that I had seen. And he did a study and submitted a plan, and basically his cost was going to be about $90,000 to put a restraint system in. Well, I looked at this for District 10, and basically his design approach had quite a few holes in it, and economically, when it was all said and done, we could dig out and replace that embankment 3 times for the same cost of putting in that restraint system. What that tells me is that 39 years from now, we'll have spent the same amount of money, and at least we've dealt with the problem one way. It wasn't entirely effective, or it may not be entirely effective to dig it out and replace it, but today's cost is much less, and I think that certainly if it's done right, the dig out and replace can be a very effective method. So the point there is that the best solution isn't necessarily the most effective because of cost. In honor of Gene Geiger, this is what he ends every presentation with, so little words of wisdom to not skimp on the foundation. And I've only been here 6 months, haven't been here through a spring yet, so I would imagine that I'll be talking to you guys a lot more after this spring and after this spring. So that's the end of my presentation.
Okay, why don't we go ahead and take a seat so we can get started. We can go to lunch here at the Pleasant Hour. Okay, for those of you that are following on the manual, we're going to start on page 13. We're going to talk about what makes the slope move. Before we can get into a discussion about how to correct a slide or what kinds of preventive maintenance to do, we first need to determine the causes of the slide. So what makes a slide move, and so that's what we're going to get into here. Okay, if we look at this slide here, and we see that, let's see, we have a fence line going through here, and then all of a sudden, we don't have a fence in this area. The fence is way down over here. So, you know, we essentially have a failure taking place here. Now, why did it fail here and not in this area or not in this area? Okay, that's a question that we need to address before we start looking at remedial, you know, how to correct it or do maintenance there. There's a much more problem here. This is on an approach embankment, and obviously this approach embankment here is moving out here and causing a problem there. Now, why did it fail here and not on the other side? Okay, why did this one fail in this area here and not here? Okay, so let's look at the causes of some of the problems. What are some of the causes of slides? Can we get a little discussion? Maybe some of you guys can tell me what causes a slip or a slide or whatever you want to call it, a stability failure.
Water in the wrong place?
So water, as you'll see, is a primary cause of problems. So let's start out with causes. And we're going to say that water. Water is definitely going to be one of them. What is another cause? Erosion is related to water, but yes, definitely that's another big cause. Okay, what do we do a lot of times when we're building a highway? We go out there and remove soil, so we're removing lateral support. So that might be another cause.